Hello guys, welcome to the Cloud Lunch and Learn Marathon. Myself Abhinav and I am going to give a presentation on a shadow light to Kubernetes, Jenkins and Docker. So let's see what we are going to see in this particular session. First of all, we are going to see the virtualization, then we are going to see the Docker, and then Kubernetes, and at last we are going to see the Jenkins. Let's get started with the virtualization. Virtualization is a word that you have probably heard of. However, this concept dictates the way we interact with the technology in the present day. Virtualization is a very important building block for cloud computing. Basic idea about virtualization is that we try to create a virtual form of a computer hardware or a computer resource. This computer resource can be a storage, computing server, networking, or even an operating system. Virtualization refers to the creation of a virtual rather than a real version of something, including virtual computer hardware platforms, storage devices, and computer resources. In other words, virtualization can also be perceived as a technique which allows us to share the physical instance of a resource or an application among multiple customers and organizations. Let's see the benefits of virtualization. Firstly, it helps in saving lots of cost and allows to easily maintaining it in the less cost. Secondly, it allows multiple operating systems on one virtualization platform. Thirdly, it removes the dependency of heavy hardware to run the application. Fourth, it provides consolidating servers that are used for crashing of a server purpose. Fifth, and at last, it reduces the amount of space being taken by data centers and the company data. So at last, for the virtual plus realization means the virtualization, we are going to see how virtualization is helping many people or providing IT infrastructure. So there is a user has multiple apps running or the devices running in the physical or the virtual environments. So what a user does, user just added them with the policies or the preferences, settings or the rights. It's just adding them and providing it to build an IT infrastructure which we are using. For example, you are using a virtual machine over cloud. It is all about the virtualization. So, in the second part of the presentation, we are going to see Docker. Docker is a set of platform as a service products that use operating system level virtualization to deliver software in packages called containers. Before learning Docker, we are going to see what are containers. A container is a software package that offers maximum portability while being infrastructure agnostic. By containerizing your application, you are building a package that holds not only your application but all the dependencies needed for that application to run. From an execution standpoint, containers are major divergence from traditional virtual machines, where virtual machine host entire guest operating system that act like standalone servers. Containers are simply isolated processes that running directly on the host operating system via a shared kernel. So guys, let's get started with Docker. Docker is a container platform which is running always on the top over the operating system. And here we are going to see the Docker engine. So what Docker engine consists of? Firstly, it consists of a Docker daemon which is the server. Over that there is a Rust API running over it. And at last at the outermost there is a client or the Docker CLI which is connected to the network, containers, images and the data volumes which we can control by the Docker CLI, and it is used to totally manage everything inside and outside of the Docker. So, Docker is a place where you would like to run multiple applications on the same host, but you need them to be isolated for the security reasons. You either need to move the applications into separate hosts, which is not cost efficient, or you would like to run two different virtual machines in the host, which would give you the isolation, but the resources will be consumed by the virtual machines most rather than your application, which is still not the best way. These problems have existed for decades now. Keeping the processes separate is a huge pain, and this caused a lot of security problems as well as inefficient setups in the past. So guys, now here you can see Docker versus virtual machines. There are Docker containers. Docker containers contain binaries, libraries, and the configuration files along with the application itself. They do not contain a guest operating system for each container and rely on the underlying operating system kernel, which makes the containers lightweight. Containers share resources with other containers in the same host operating system and provide operating system level process isolation. Secondly, we have the virtual machines. Virtual machines run on the hypervisors, which allows multiple virtual machines to run on a single machine along with its own operating system. Each virtual machine its own copy of an operating system along with the application and necessary binaries, which makes it significantly larger than it requires more resources. They provide hardware level process isolation that are slow to boot. So let's see, you have 1 GB of container image. If you wanted to use a full VM, you would need to have 1 GB times or into the number of virtual machines you want. With Docker allows you can share the bulk of 1 GB between all the containers, and if you have 1000 containers you still might have a little over 1 GB of space on the container operating system, assuming that all are running on the same operating system image. A fully virtualized system gets its own sets of resources allocated to it and does minimal sharing. You get more isolation, but it is much heavier or requires more resources. With Docker, you get less isolation, but the containers are lightweight, require fewer resources. So you could easily run thousands of containers on a host and it does not even blink. So, in the third section of the presentation, we are going to see Kubernetes. What are Kubernetes? Kubernetes is an open source platform or the tool created by Google. It is written in Go language. So currently Kubernetes is an open source project under Apache 2.0 license. Sometimes in the industry, Kubernetes is also known as K8s. With Kubernetes, you can run any Linux container across private, public, and the hybrid cloud environments. Kubernetes provides some edge functions such as load balancers, service discovery, and role-based access control, also known as RBAC. So, why we need Kubernetes? The answer is to help us to manage containers. When we run our production environments using a microservice pattern with many containers, we need to make sure many things such as health check, version control, scaling, and rollback mechanism. It will be very frustrating to make sure all of these things still be okay. Kubernetes gives you the orchestration and the management capabilities required to deploy containers at scale. Kubernetes orchestration allows you to build application services that span multiple containers, schedule those containers across a cluster, scale those containers, and manage the health of those containers over time. In a nutshell, I can say Kubernetes is more like a manager that has many subordinates or the containers. What manager does is maintain what subordinates need to do. Before you use Kubernetes, you need to prepare your infrastructure to deploy a new microservice. I believe it cost you a few days or a weeks. Without Kubernetes, large teams would be have to manually script the deployment workflows. With Kubernetes, you manually and it will reduce the amount of time and resources spent on DevOps. So let's see first topic of why we need Kubernetes, that is horizontal scaling. The horizontal pod autoscaler automatically scales the number of pods in a replication controller or deployments or replica set of stateful set of observed CPU utilization or with custom metric support on the other application provided metrics. Note that horizontal pod autoscaling does not apply to objects that can't be scaled. For example, diamond sets. Secondly, autoscaling. Kubernetes will automatically scale up your cluster as soon as you need it and scale it back down to save your money when you don't. Third, health check and self healing. The kubelet use liveliness probes to know when to restart a container. For example, probes could catch a deadlock where an application is running but unable to make progress. Restarting a container in such a state can help to make our application more available to despite bugs. The kubelet uses readiness probes to know when a container is ready to start accepting the traffic. A pod is considered ready when all the container of the set is ready. One use of this signal is to control which pods are used at the backends for service. When a pod is not ready, it is removed from service load balancers. The kubelet uses startup probes to know when a container application has started. If such a probe is configured, it disables liveliness and readiness checks until it succeeds, making sure those probes don't need any interface with the application startup. This can be used to adopt liveliness checks on the slow starting containers or avoiding them to getting killed by the kubelet before they are up and running. So now we are going to see the architecture of the Kubernetes. Kubernetes contains the API server, which is a centralized component where all the cluster components are communicated, where like scheduler, controller, manager and the other worker node component communicate with the API server. Scheduler and controller manager request information to the API server before taking any action. The API server exposes the Kubernetes API. Scheduler is responsible for assigning your application to the worker nodes. It will automatically detect which pod to place on which node based on the resource requirements, hardware constraints, and the other factors. It will smartly find out the optimum node which fulfills the requirement to run the application. Then there is a controller manager. The controller manager maintains the cluster. It handles node failures, replicating components, maintaining the correct number of port, etc. It constantly tries to keep system in the desired state by comparing it with the current state of a system. etcd is a data store that stores the cluster configuration. It is recommended that you have a backup as it is a source of truth for your cluster. And if anything happened, you can restore all the cluster components from this stored cluster configuration. etcd is a distributed reliable key value store where all the configuration is stored in a documents and it's schemaless. We have the worker node too. The worker node are nothing but a virtual machines running in cloud or on premises. A physical server running inside your data center. So any hardware capable of running container runtime can become a worker node. These nodes expose the underlying compute storage and networking to the applications. We have kubelet. The kubelet runs the manages the container on node and it talks to the API server. The scheduler will update the specification or the node name with the respective worker node name, and the kubelet controller will let a notification from the API server and it will then contact the container runtime like Docker for example to go out and pull images that requires to run the pods. The kube proxy load balances traffic between application components. It is also called as service proxy, which run on each node in the Kubernetes cluster. It will constantly look for new services and appropriately create a new role on each node to forward traffic to services to the back end pods respectively. Container runtime, where the container runtime is something which runs the container like Docker, Rocket, or the container. Once you have the specification that describes your image for your application, the container runtime will pull the images and run the containers. Pods are the smallest unit for the deployment in Kubernetes as containers is smallest deployment in Docker. Kubectl is a command line utility through which we can communicate or instruct the Kubernetes cluster to carry out the certain task. With this, we can control the Kubernetes cluster manager too. As we've seen, Kubernetes components together create an architecture terminology. These core components work seamlessly to provide the best user experience. In this fashion, Kubernetes architecture makes it modular and scalable by creating an abstraction between the application and the application which has underlying infrastructure. So, in the fourth part of the presentation, we are going to see Jenkins. Jenkins is a free and open source automation server. It helps automate the parts of the software development related to building, testing, and deploying, facilitating continuous integration and the continuous delivery. So, what is Jenkins? Jenkins is a self sufficient open source automation tool written in Java. Jenkins uses plugins to build and test your project code continuously, makes new changes, a laid back approach for developers. Jenkins facilitates continuous integration, hence, it is preferably installed on a server. Why Jenkins? Even mundane tasks can get complicated with the company's growth. However, when automated, more energy can be focused towards its growth. Jenkins practices pipeline as a code concept that practices automation. Jenkins can handle both parallel and the distributed builds. What's a pipeline approach? Unlike the traditional approach, the pipeline doesn't wait for the entire process to be completed to look into bugs and errors. This has been a game changer for developers. Jenkins supports over 1,000 plugins to support and handle various software plugins can be installed, updated, and removed through the Manage Plugin screen. Jenkins is highly extensible, whose functionality can be extended through the installation of plugins. When working with Jenkins, the continuous build, integration, and the testing relative tasks associated in the project is called the pipeline. Pipeline manages the continuous delivery process. Because of this, do not mistaken the pipeline to be stuck and ineffective as they evolve throughout the projects. Jenkins has a Jenkins files that handles creation and execution. A continuous delivery pipeline facilitates an automated expression that processes the software through version control to your users and customers. You can code a simple or a complex task via pipeline DSL, also known as domain specific language. A pipeline is a collection of jobs that brings the software from version control into the hands of the end users by using automation tools. It is a feature used to incorporate continuous delivery in our software development workflow. Over the years, there have been multiple Jenkins pipeline releases, including Jenkins Build Flow, Jenkins Build Pipeline Plugin, Jenkins Workflow, etc. What are the key features of these plugins? They represent multiple Jenkins jobs as one whole workflow in the form of a pipeline. What do these pipelines do? These pipelines are a collection of Jenkins jobs which trigger each other in a specified sequence. Let me explain this with an example. Suppose I am developing a small application to deploy it. To I want to build, test and deploy it. To do this, I will allocate three jobs to perform each processes. So job 1 would be for build, job 2 would perform test, job 3 for deployment. I can use the Jenkins build pipeline plugin to perform this task. After creating three jobs and chaining them in a sequence, the build plugin will run these jobs as a pipeline. So, whatever I have explained till now, these all are the part of DevOps. DevOps is a set of tools and practices that help organizations build, test, and deploy software more reliably and at a faster rates. DevOps is enabling organizations to evolve and deliver their products more quickly than those with a traditional development and release cycle, which can provide a competitive edge. Rather than pushing out a release once a fortnight or no longer, new features can be delivered to the users daily, and bug fixes can be deployed in hours, all following the same repeatable automated pipeline. And at the end, I want to put a quote by a great person staying in Morris back. Any roles involved in a project that do not directly contribute towards the goal of putting valuable software in the hands of users as quickly as possible should be carefully considered. Means you have to take care of everything which you are putting inside your software at the end. So, thank you for listening to me on the Cloud Lunch and Learn Marathon. Thank you. If you would like to connect to me, you can check my LinkedIn ID in the description. Thank you.